Hi everyone, welcome to the video on synthetic division and the remainder theorem. So synthetic division is an awesome quick little shortcut that can help us divide a polynomial by a linear binomial. Sounds fancy, but basically it's a nice little shortcut to long division. All right, so I'm just going to actually paste my work here. You don't have to do it as well. I just wanted to show you. So this is long division, which we did, I think, in Unit 1 or 2. Long division, if you guys remember, you put this on the outside, this is on the inside. Note, you fill in any zeros for missing terms, if you guys remember that. And whatever you're left over with, you put as that remainder. Okay, so this is going to be a really similar situation. And you're going to get the same answer, but we're going to do it in a different way. So again, to remind yourself, we're going to use long division still sometimes, especially when it's not linear. Like if it was x squared minus 1, we would have to use long division. All right, so if it is a linear binomial, so x to the first power is the highest, and it's 2 terms, we can use long division, and we can use synthetic division. So let's see how we would set up synthetic division. All right, so here's the new lesson. First, you set the denominator to 0, so that special number, when is x minus 1 equal to 0, that would be at x equals 1. So you should be writing with me now. Okay, so 1 is going to go on the outside, and I'm going to kind of draw this half rectangle there. All right, so then I'm going to fill in the terms. So what are my terms? 3, just the coefficients, no x's, 0x squared, negative 4x, and 2. All right, so notice that I did not put any x's, and also I put a 0 where there was an x squared missing. All right, so let's see what happens here. So what you're going to do, it's the same process every time. You'll get pretty quick at it, and it's relatively enjoyable, actually. But to start, just stay with me. We're going to bring down the first term. Then we're going to multiply 1 times 3, and we get 3. So 1 times 3 is 3. Okay, then we add these two together. 0 plus 3 is 3. Okay, next, multiply 1 times 3 is 3. So again, multiply, then add. Negative 4 plus 3 is negative 1. All right, then we multiply again. 1 times negative 1 is negative 1. Okay, and then we add. 2 plus negative 1 is 1. Okay, I'm going to put a little square around that. That's actually going to be the remainder. Okay, and let's see what we have left. This was an x cubed term. Whenever we divide by 1 power, this is going to be the next term down. So this is going to be an x squared term. We're going to take away 1 power. So let's see what we have, guys. We have 3x squared plus 3x minus 1, and then plus 1 over x minus 1. Oh my gosh, same answer. So same exact answer we would get with long division. And if you guys remember long division, it kind of took you a while. It was kind of a longer process. So again, what we did there, we get those terms left over, and we would rewrite that if we're dividing. We rewrite it as a polynomial. Okay, so again, you start with a power below the power you started with. It was x cubed. We divided 1 power out, so now we're at x squared. Okay, we're going to try a few more. So if you're totally lost, you could always rewind, but you're about to see another one. So let's set this one up. So we're going to try out A here. Okay, so the first thing you do, again, we could do long division, but we're going to try this again called synthetic division. You put negative 4 on the outside. I picked negative 4 because I set this equal to 0. Okay, then I have my highest power is 4. My coefficient is 1. So make sure you have every power, 4, 3, 2, 1, 0. Okay, so I don't have to fill in any zeros. I have every slot filled in. 4, 2, 9, 4. So I write in those coefficients here. If there's negatives, you should put negatives. These are all positive. All right, so let's see if you remember the process here. Bring down the first term. We multiply. Negative 4 times 1 is negative 4. Okay. 4 plus negative 4 is 0. Next, we multiply. Negative 4 times 0 is 0. 2 plus 0 is 2. Negative 4 times 2 is negative 8. 9 plus negative 8 is 1. Okay, negative 4 times 1 is negative 4. And negative 4 plus 4 is 0. Okay, which is exciting because that means the remainder is 0. Okay, so what do we have left? This said to divide. So our answer is going to be a polynomial. We started with an x to the 4th, so this is going to be an x to the 3rd. We bring it down 1 power. So we've got x to the 3rd, or 1x to the 3rd, plus 0x squared, plus 2x plus 1, plus 0 over x plus 4. So we don't really need this or this. So my final answer is x cubed plus 2x plus 1. And that is it. All right, we're going to try out B. Let's try out one more here. See if we've got that process down. Okay. And once you get it down, guys, the rest of this, a lot of this unit is going to be using this in different ways. So synthetic division's, first of all, super important. And also once you get it down, it's going to be useful throughout. So on the outside, we put negative 2. 6 power is the highest, so I need a 6th power, a 5th power. It wasn't there, right? So we were missing 0x to the 5th. A 4th power, a 3rd power, a 2nd power, a 1st power, and a 0th power. Okay, so lots of terms here, but again, that same exact process. Bring down the first term, multiply. Negative 2 times 1 is negative 2. Add 0 plus negative 2 is negative 2. Multiply. Negative 2 times negative 2 is 4. If I'm going too fast, take a pause. Go back if you need to. Negative 3 plus 4 is 1. Then we multiply. Negative 2 times 1 is negative 2. Okay. This would be 0. Negative 2 times 0 is 0. Add. Negative 6 plus 0 is negative 6. Okay. And then we've got negative 2 times negative 6 is positive 12. Negative 5 plus 12 is 7. Negative 2 times 7 is negative 14. And last but not least, our remainder is going to be negative 11. Okay, this was an x to the 6th, so now this is an x to the 5th. So let's write this out, guys. 1x to the 5th minus 2x to the 4th plus 1x cubed plus 0x squared minus 6x plus 7 minus 11 over x plus 2. Whew, that would have been really a lot of lines of long division, so it's awesome to use that shortcut. And yeah, if you are stuck or confused on synthetic division, honestly, I think you should rewind and go back because that's all we're going to continue to do here, so make sure you feel okay about it. Again, notice that these instructions said divide, and my answer looks like this. So it looks like a polynomial. Okay, now remainder theorem. Okay, this is kind of interesting as well. Still synthetic division. If we divide, the remainder is equal to f of k. All right, so what that means is if I ask you what is f of negative 1, which is, this says find f of k, so f of k would be what is f of negative 1? Well, typically you guys plug in negative 1, right? So you would do f of negative 1 is negative 1 cubed minus 4 times negative 1 squared plus 2 times negative 1 plus 1, right? That's what you would typically do here, okay? And you would get, let's see, negative 1, this would be minus 4 times 1 minus 2 plus 1, which gives me negative 5, negative 7, so negative 6. Okay, so in a general sense, let's say we didn't know synthetic division, our answer is negative 6. Now, if I told you some more difficult number or you didn't have a calculator, I mean, negative 1 isn't that bad, but let's say I said find f of 20. Okay, that might be a little more annoying to cube and square. So I want to show you a different way of finding f of negative 1. Okay, we're going to set up long division. You're going to use, synthetic division. You're going to use k as that outside number. It doesn't need to be opposite, just use exactly what it is. So negative 1, we're going to fill in 1x cubed minus 4x squared plus 2x plus 1. Okay, we're going to do some synthetic. Bring down the first number. Negative 1 times 1 is negative 1. Add negative 4 plus negative 1 is negative 5. Negative 1 times negative 5 is 5. Then we get 2 plus 5 is 7. Negative 1 times 7 is negative 7. And your remainder is negative 6. Hey, look at that. So you'll notice it's the same exact thing here. Okay, so we get f of negative 1 is negative 6. So by the remainder theorem, meaning whatever this remainder is in synthetic division, it's the same thing as plugging in negative 1 for x. Okay, so when it says find f of 3, we'll do this one in class, but you guys are going to end up setting up this. 3 and whatever this remainder is going to be your answer for synthetic division. Remainder theorem. Okay, so what if we get a remainder of 0? Okay, so we're going to just talk briefly about this little section here, and then example 4 and 5 we will try in class. All right, so just stick with me here for example 3. Let's see what's going on. So what if I get a remainder of 0? So meaning, you know, I plug in 3 and at the end I get 0 right here. All right, that means, really important here, okay, it is a root, an x-intercept, a solution, or you could call it a 0, meaning it is one of the factors or it is one of the roots. Again, that's called factor theorem here is going to be x minus k is a factor. So all these letters I think confuse people, but let me show you what I mean on this graph. Okay, so if I said, what are the zeros on this graph? Verify your solutions. So take a look at this guy, x squared minus x minus 6. If I said solve for x, I think you could probably easily do that, right? You would just factor. Okay, you would get x minus 3, x plus 2. So my zeros, or my solutions, would be 3 and negative 2. All right, well, take a look at this picture. What do we got? 3 and negative 2. That's where I would cross the x-axis because solutions are also x-intercepts. So start connecting that in your head. All right, solutions, x-intercepts. What else does this mean, though? Okay, so let's try one more thing. I'm going to just show you why does synthetic division help us here. Now, obviously, on this one, we can do by hand, but if I gave you this problem, if I said factor it, I don't think you would know how. That's not something we know how to factor unless it works with grouping or something nice like that. So yes, I'm showing you an easy example because we can actually factor and prove it. But in a general sense, we're going to have more complicated things where we can't factor right away. So let's set up synthetic division. What if I said, is 3 a 0? So if I put 3 out here, okay, 1, negative 6 for those 3 coefficients. I bring down a 1. 3 times 1 is 3. Negative 1 times 3, excuse me, negative 1 plus 3 is 2. And 3 times 2 is 6. Negative 6 plus 6 is 0. Okay, this means 3 is a 0, or root, or x-intercept. It also means x minus 3 is a factor. Okay, so yes, we know how to factor this, so good news, we actually already knew that. But in a general sense, if we didn't know how to factor it, we could actually prove something's a factor this way. So let me show you one more kind of cool thing here. What's left over, guys? If this was an x squared, I hope you guys know this would be 1 power less. This is an x. So what I have left over is x plus 2. Huh, interesting. That's the other factor left over. So when I divide out an x minus 3, that's what this really represents. I'm left with x plus 2. Because if I divide by x minus 3, they would cancel, right? And I would just get x plus 2. So that's kind of cool too. We can actually use this for division. We can use it to prove it's a 0. We can show it's a factor. And same thing if you guys picked, I'll show you just the end here. What if I said, is negative 2 a 0? Which you guys said it was from this picture. But if this was a more complicated problem, 1, negative 6. 1, negative 2 times 1 is negative 2. Negative 1 plus negative 2 is negative 3. Negative 2 times negative 3 is 6. So again, yes, you would say negative 2 is a 0, okay, or root. You also know that x plus 2 is a factor since the remainder was 0. And what I have left here is x, 1x minus 3, meaning if I divide out an x plus 2, that's what I would have left. So I just want you guys to see that connection, and I hope you do. All those things are very, very connected. 0 being a remainder is really important because it tells us about roots, and it also tells us about factors. So that's what we're going to continue below. For example, 4 and 5, we're going to pull this all together. Make sure you're feeling good about synthetic and in general what a 0 means, which right here, you've got all your information. What does it mean if I have a 0 remainder? Okay, and we'll finish up in class. Thank you so much for watching.